Welcome to the D2 Incorporated Water Separation Instrument demonstration video. In this video, we're going to demonstrate to you the water separation instruments, better known as WSIs, WSIs, that are used for determining the filterability of fuel, mainly jet fuel. In this video, we're going to run a few samples on these devices and run you through the features of the devices while we're going through the samples. So, first off, to turn the units on, each unit has a power button on the side and a power connector. This power connector connects right into a 3-prong outlet. So to turn the units on, you press the only button on the device, which is the on button. Same thing on this unit, and that turns the units on. Now quickly, before we run through the menu features, let's run through the actual features of the device that we can see just by looking at it. It's a touchscreen device. It has a patented sonic mixer. On the back, it has a waste bottle jar, a solvent jar, which is isopropyl lab-grade alcohol, and a water jar, which is water and fluorescent dye. On the side, it has a cup holder, and we sell these 230 milliliter cups. They're actually 250 milliliters, but you put a 230 milliliter fuel sample into each. And we sell these, which are filters, inside a vacuum sealed bag. When they come out, they look like this, except they have an RFID tag on the bottom, which I'll show you once we open up the new filters to run the test. On the device itself is the RFID tag reader, and this is where the filter goes. And these units are very, very easy to use. So now let's run through the menu features. It's a touchscreen device, so to open up the menu, you just tap on the screen. You have 4 buttons. The top one runs the test, and we'll get to that one last. The bottom left one is resources, which shows you the display version, the controller version's firmware, and the detector version's firmware. You can set the volume on the device by using this bar here, and you can set the backlight on the device with a similar bar. Under the maintenance tab, you can calibrate different things on the device, such as the water pump, which takes you through a step-by-step guide. You can calibrate the fuel volume, which also takes you through a step-by-step guide. And you can calibrate the mixer, which is another step-by-step guide. When you first turn the unit on and you put this little water bottle on the back, you can see the green line that runs from the water bottle into the back of the device there. And then it comes back out here and down into the sample cup, where the sample cup would be. That line, as you see, is solid green because it has water with the dye in it. You want to make sure it's solid green, and in order to do that, once it's already hooked up, you would press the prime water pump button, which then sends a tiny bit of water out of it, as you can see there. And if you had just put the unit on and just added that to the device, what you'd do is you'd hit this button here, change water bottle, which would cycle a whole bunch of the water through. The reset bottle values button on the top right is what you would press if you wanted to change any of the values for the bottles on the back. Our unit keeps track of how much is in each one of these bottles based on how many times you've run the test since you last hit the reset bottle values button. So if we click on that, you can see it's telling you that the waste bottle is 80% full, and that's pretty true looking. Also, it's saying that the water bottle is 88% full, and that's also pretty true, and the solvent bottle is about half full. So we don't need to clear any of these values, but if we had emptied the waste bottle, we could come back here and hit clear on the waste bottle value. Now to go back on any screen, you just hit this button on the bottom left, the back button. The last button we have is the functionality button. On here you can start the fuel pump, you can start the mixer wand, you can turn the filter on and off, which is the filter here, so that would be to put fuel through it or not. You can check the fuel temperature if you had a sample cup in there. You can check the fuel conductivity. When I hook up the barcode reader, when we run the test, you can always check if the barcode reader is working by pressing this button here and scanning something with the barcode reader. And this button here, when you press this starts the card reader mode. And basically every time you run a test on this device, it keeps a text file of every piece of that data and the final average for the WSI value. And it puts all of that into a text file internally. And the way you access that to a computer is you just hook a computer into this top USB port here, which is just a mini USB port. And that hooks into your computer, and when you turn this into the card reader mode on, which we have on now, that turns us into basically a USB flash drive. So it'll pop up on your screen, allowing you to open and view the files. And then every test that you've run is time and date stamped and has every data point that was taken during the test and the final values. And to get out of this, you just click on it again to go back to USB mode, and then you return back to the main screen. So next we're going to go ahead and run a sample. In this portion of the video, we're going to be running some fuel samples on the water separation instrument and showing you how the device actually operates. Now we have two units set up side by side so that I can show you how accurate they are when running the same type of fuels. And we're going to run two types of fuel samples. The first one is going to be just a standard fuel that should give us a perfectly good WSI value. And the WSI value is based on the trademarked MSEP value. So it's the same scale. The only difference is you do not have to adjust for SDA's presence on our device because our device has eliminated the issue with SDA in the fuel. So in order to start the test, all you do is you go over here and you hit the start button on run test. So you hit run test, run test. If it shows up with an empty waste bottle, as the screen on the right does, that just means the waste bottle in the back might be full. So you want to check it. It isn't. If it isn't, you just hit back, and then you hit run test again. On here, you have the operator name on both sides, which is Dean. To enter that, you just click on it, and you type in your name. If you spell it wrong, say I put in Diener, and I want to go back, I just hit the delete button, which deletes the last character, and then I hit enter to finish. The device on the left has the sample ID capability hooked up to a USB barcode reader. So this barcode reader, which hooks into the lower of the two USB inputs, allows us to take a barcode from a jet fuel sample like this one, which reads jet fuel 8, and instead of having to manually enter that in, we can just simply take our barcode scanner and we can scan our jet fuel sample, which then puts it right into the sample ID for you, which makes that an automated process as well. And if we do not have the barcode scanner or our sample does not have a barcode on it, we can just enter it in. Once we've entered in that information, we hit next on the screen, which then prompts us to add fuel. Each sample we run takes 230 milliliters of fuel. We sell these cups, and when we sell them, they come already pre-marked with the little marking at 230 milliliters. They hold about 250 milliliters, so there's a small gap at the top so you don't spill, and you just place that right into the cup holder. And we'll do the same thing on this device over here. Okay. Once that's been done, you can hit next on the screen. And then you lock the sonic wand down into place. In order to do that, you simply take the sonic wand, which is here, and push it down like so. Once it's all the way down, push the button to lock it into place. Same thing on the other side. Push it down. Once it's down, lock it into place. And then on the screen, you hit next, and we hit next. All the filters come in vacuum sealed bags like so. So you just simply take it out of the vacuum sealed bag. Each filter has a little RFID tag on the bottom, which is read by this RFID tag reader here. So you do is you just take the RFID filter and you put it in, and then you snap that on like so, and that's how the filter fits. The new filters are beveled, so no fuel will spill out, but these are just sample demos used for this video, so a tiny bit of fuel might come out. Ones without the RFID tag, or ones that have already been used, will trigger the system, and it won't recognize, because this one does not have a tag, that there's a filter there, but it won't stop you from running the test, and I'll show you how that works. So we're going to run one without the RFID tag. So next process, you simply hit next. If it recognizes the RFID tag, it'll go right into the thing, and from this point on, you don't hit anything. On this one, because there's no RFID tag, it's going to trip an error. You can see here, no filter detected. You can either quit by pressing the X, or you can continue because there actually is a filter there, it just doesn't have an RFID tag. And basically it's not recommended to use any filters that this happens when you do it. That's because either the filter's been used, it might not be a filter that we made, which means it wouldn't have one of our tags on it, or any other reason. So always try to use new filters that have tags that do not bring up this process error. Once you are ready to go, you hit next. And as you can see over here, the unit has already started priming the filter. And basically what it does is it takes fuel from our sample and it primes the detector by flushing fuel through the detector to get rid of any of the IP solvent, which is just isopropyl alcohol that might be left on the detector. And then it flushes through the filter with fuel. And after it does that, it will start the mixer process, which will mix the water and fuel sample together. Set it up over here so that we can see both units as they're running at the same time. So at this point in time, you'd normally be off running some other sort of equipment instead of sitting here watching the devices. However, that is a great benefit to any lab technician because that just opens up more time for him to do other work. Now you can hear on the left the mixer process has started. So what you can see here happening on the left, if I zoom in a little bit, is you can see the bubbles in that cup. And basically what's happening there is the water is being mixed into the fuel, which forms droplets. Those droplets then fall to the bottom of the fuel sample, and our sonic mixer, which is a patented pending item on our device, then mixes using sound and vibration the water droplets into the fuel. And at the end, what you're left is a emulsified fuel sample with 10 micron water droplet size in a uniform pattern throughout the fuel. And the reason we turn the mixer on and off is because as you mix the water droplets up into the fuel, they mix up and then they go back down into the fuel, and then the mixer kicks them back up and mixes it back up into the fuel. So this goes on for a couple of minutes. Zoom back out, and the mixing process is almost done. Sorry for the phone calls in the middle of that, but we are a business. The mixer cycle is continuing. That'll continue on for a couple minutes until we have a fully emulsified fuel sample. This is showing you one of the major benefits of the unit, because in previous test methods, the operator would have to stand there and mix the sample as the test was being run. So the mixer cycle continues on for a little while, and basically all it's doing is it's taking water from the water bottle on the back here, and it's pumping that down into the sample. And once that is completed, it will start by priming the filter. Another one of the benefits of our device is little pop and play filters, which we sell at D2 in packs of 10, and those basically turns the device into a Keurig, because those are the only disposables you need in between every test other than the fuel sample. Now you can see here on the left device, if I zoom in a little bit, the trend line has started as it's starting to acquire the reference data. So basically what happens here at the very first spike is isopropyl alcohol going through the detector as the detector is being flushed, and then the fuel comes in, and then the fuel will go across here as you get a baseline for the fuel as it goes through the detector without going through the filter. And the unit on the right is just a little bit behind because I was showing you how the RFID tag holder worked. And now that is caught up and is acquiring the reference data as well. These units run on roughly the same time because they're automated and there's no real way to change how long the test takes. The test roughly always takes about 8 minutes and 55 seconds. You can see the left unit is now flushing out the detector, and then with isopropyl alcohol, and then it'll start acquiring the filtered data for the fuel. So now the unit on the left is pushing fuel through the filter, and then the fuel is going by the detector. So all the fuel that's going by the detector now is passing through the filter, so it's checking for the filterability of the fuel. You can see it always starts at a little spike because of the isopropyl alcohol, and then if it's good fuel, it should settle on the bottom line and go all the way across. Now the unit on the right is flushing out the detector, and it will start acquiring its filtered data. And you can see the unit on the left, because it's one of the older styles of the filter, is allowing some of the water and fuel to pass through it. because it's not as good of a filter. And the filter on the right, which is one of our newer filters with the bevel, is not allowing any of the water to go through, and the fuel is being filtered perfectly. So here you're seeing the difference of how fuel filters can be affecting how the fuel is actually filtered. And now the unit on the left is pushing all the fuel through the filter, so you're seeing how the fuel is being filtered by the filter as it rides along the baseline. It's important to note that our device actually works by taking a measurement continuously every time the fuel passes by the detector. So unlike other devices that wait for the fuel to fully pass through, then checks the coalescence at the end, ours is actually directly checking water filterability, because we're mixing water into the fuel and then we're checking to see how much of that water passes through the filter. So this is a direct check for water filterability, which makes our device far more accurate than anything else in the field. And also you get a huge amount of data because all of that data is stored internally on the device. So basically the device has all of these data points in it that you can go back and check. And as I showed you earlier in the video, the USB card reader mode allows you to go in and extract those text files with all that data so you can analyze this for yourself. And you can see both fuels, because they both are good fuels with no surfactants in them, and surfactants would kill the filters, and these filters are working just fine and the fuels are being filtered just fine. That baseline, if it were to go up, that would mean that water has now started passing through the filter, and that would mean that the fuel is actually bad. This process continues on for a couple minutes until most of the fuel and water mixture emulsification has been pulled out of the sample cup and put into the waste container on the back of the unit. Of course, this is all fully automated, so you don't actually have to sit here and watch these units as they operate, but if you want to, you can, which is why we added the graph to the screen so you could see what was going on in real time. As for the maintenance of the unit itself, there's nothing on here that would require replacement. As for spare parts, the only spares you'll ever need are the little filters that you need every time you run the test, your own fuel, isopropyl lab grade alcohol, which fills up the little alcohol bottle in the back. And we sell these water dye bottles which fit onto the back here as spares, and those last about 500 tests. So you won't need too many of those in order to use the units. So you can see both fuels are still being filtered through the filter and no water is getting through, which means these are good fuels. And the WSI value, which is on the same scale as the trademarked MSEP value, should be, around 100 or 98 or something of that nature. We built these units in partnership with SATA Analytics, and we are D2 Incorporated, which is why you have multiple logos on the device. The unit on the left has just finished, and now it is flushing the detector at the end with isopropyl alcohol, and then it will display the results on the screen. Okay, and there are the results for this fuel run. So it gave you the filter ID from the RFID tag, it recorded the fuel sample temperature. We do not yet have the conductivity differential results displayed on the screen, and the WSI value for this fuel was a 100, which means it's a perfectly good fuel. And that's exactly what we were expecting to see. Now the unit on the left is just finished. So after it finishes flushing the detector, it should give us the results, and I expect them to be roughly similar to the results from the last test. And they are, of course. So here we're going to run a second sample, and this time we've added some AOT to the samples, which is a surfactant, which should give us a lower WSI number. This is the surfactant I added. It's AOT. It's what the test method is based on. And basically, we've added the same amount to each cup. We've got another 230 milliliter fuel sample on each device, and we're going to start all over and show you how accurate these are when you have a different result than a perfect fuel. So we're going to click on the screen, hit run test on each. The one on the left has the barcode scanner, so I can simply scan the barcode. Which then adds the sample ID to the screen. And over here, I got to enter the sample ID in, so just real quick, jet fuel 8. Oh. 8, like that, perfect. Okay, and then you hit next on both screens. And it tells you to add the fuel, which we've done. So you hit next, lock the sonic wand down, locked, next, add filters. These filters don't have RFID tags on them. Normally they would, so we'll just skip by the process error that I already showed you. You would normally never want to use filters that do not have our RFID tags on them, so please do not use any that do not. You hit next once the filter's in there. Both units are going to tell you there's no filter because it didn't read the RFID tag, so always use units, always use filters that have RFID tags. But if they don't, for some reason, like here, you can still continue just by hitting the continue button. So we're going to do like that. Now both units are going to go through the same process as before, except they're going to do it at the same time. And I'm just going to let the video run, and you can just watch it as it takes place. So first, it's priming the no filter, and basically it's just clearing out any of the isopropyl alcohol that might be in the filter. And now it's priming the filter itself by running fuel through it. You can see it's a very simple process to start and run. And like a Keurig, all you have to do is add your fuel in your little filter and you hit play, and that's all you got to do. So it's a very simple process. It's very easy to use. There's basically no user training on these devices, and it eliminates a huge amount of the human error in the previous equipment and other test methods. After it's done priming the non-filter detector and the filter itself, it will then go ahead and start the mixer process. These units are for sale through D2 Incorporated in North America and through Stanhope SATA, also known as SATA Analytics, outside of North America. So now you can see the mixer cycle has started, and both units will turn the mixers on and off in order to mix the water droplets up from the bottom of the cup into the rest of the sample. And as it's doing that, it's continuing to add water from the water bottle, which has water and fluorescent dye in it. And the unit operates basically on the principle that the water, which has dye in it, once it goes by the detector, will trigger the detector with the dye. So So we're really measuring how much water is getting through the filter. You can see now both the fuel samples have a fairly good amount of water mixed into them. You can see from the green coloration of the sample cups. And as I noted before, you get a very uniform water droplet size of around 10 microns with these sonic mixers, which are patented bending. And the accuracy of our device really is down to the sample preparation, which is taking place right in front of you, because we're able to put uniform amounts of power into each sample, and the samples are uniformly emulsified every time. In any unit where you'd be manually preparing the sample with a handheld mixer, obviously human error takes place and the samples are always different. This also removes the need to have someone trained on the ability to mix the sample while they're running the test. The mixer cycle continues on until the sample is fully emulsified, and then it should kick into the acquiring data stage. See, both units are now into the acquiring reference data stage. Basically what it's doing is it's sending the fuel mix right by the detector, so you're not getting this fuel filtered. This is just the detector reading the fuel as it's going by the detector, so you're getting a baseline for how much water is actually in the fuel. So basically the unit's determining if the filter completely failed and all of the fuel and water was just going right through the filter, what would it look like? And that's what it's doing right now. And that little spike right at the beginning of the graph that you can see on the screen is just the isopropyl alcohol that was left in the detector from when it got flushed out. Now you can see the unit on the right finished and the unit on the left finished at the same time, basically, and now they're flushing the detector with isopropyl alcohol to get any of the water and fuel out of the detector. And then it kicks into acquiring filter data. So now it's taking the sample fuel and it's pushing it through the filter. Obviously there's a small couple spikes at the very beginning because there's some isopropyl alcohol left in the detector, which just got flushed out. So you can see this fuel will probably start out fairly good with a flat bottom line, and then the AOT should kick in at some point and start causing some spikes and start allowing some of the water to pass through the filter as the AOT destroys the filter's ability to coalesce the water. see the unit on the right, there's a tiny little blip already, which means some of the water has started going through the filter. And the unit on the left is also starting to see some of the water go through the filter. And the further up that these lines go, you can see here on the right, the further that is up off the bottom, the more water that's going through the filter. And our unit's measuring as it's going through the filter, basically. So you're getting a whole bunch of data points showing you just how much water is actually going through. And you got the same thing going on here on the left. You got, it's about half the amount of water that's coming through on the right, but it's also starting to come through on the left as well. And it's important not to look too closely at these graphs as they're made, because the units are going to take an average of all these data points. So looking at any of the outliers, like a small spike in the graph or anything like that, it's not really useful information. These graphs just aren't really used for determining if the fuel is good or bad. It's just to give you a graph at the things going along so you get an idea. And generally you can tell if it's going to be good or bad fuel by how badly it's spiking and how much water is coming through the filter. But you really do need to wait for the end to get the average for both. Because like one quick glance at this and you'd say, oh, well, the fuel on this side is going to have a much lower WSI value than this. But you're not quite sure yet because you're just looking at raw data. And this process will continue on until basically those sample cups are emptied. There'll be a couple milliliters of fuel left and some water mixed into the fuel, which makes it basically useless. And of course, I've actually not done anything during this entire time. I've just been standing here by the camera speaking, and any lab technician would obviously be off doing some other work as this process went on by itself, thus saving you countless amounts of time every day where you can be off doing other stuff while these units are running these tests for you. And also it should be noted that the time to run the test is significantly shorter than the previous test methods that exist to check for fuel filterability. And that also saves you time because you can get the results in much faster. Sorry about that, the internal temperature on my camera got too high, so I had to reboot the unit. If only my camera was as reliable as the WSI. Now both units have finished, and they're flushing the detector, and then they'll display the results on the screen. And there you go. We got an 80.7 on the right unit and an 85.4 on the left unit. And that's probably because I didn't add a perfectly equal amount of AOT to both samples, because I just sort of eyeballed it. but they were roughly about the same. So we got roughly about the same results. So that's how the units work, and thank you for watching our video. If you have any questions about the WSI units, please feel free to contact me at dfougere@d2inc.com or visit our website at www.d-2inc.com.